Good day, everybody. Welcome to my channel. I hope you're fine. Today we're gonna do question 3. We last did question 2, so don't mind it now. Let's do this one today. Yeah, don't forget to subscribe, guys, please. Okay, now, November 2023 Maths paper 1. So 3.1. Given the geometric series, now we are talking about what geometric series, which means we'll be checking the one whereby if you find the ratio, it will be multiplying or dividing. And then now the series is 3, 6, 12 to n terms. Okay, so now they're saying that write down the general term for this series. So now the first thing that you must check, what is the value of a? I need to want the general term. When you know that the general term, it is denoted by Tn is equals to a times r to the power of n minus 1. And then now, what is the value of a? It is 3. So in this case, a is equals to 3. But now I need to find my ratio. What is my ratio there? How do I find my ratio using the geometric series? It is what? T2 divided by T1 is equals to T3 divided by T2. So this is the ratio. So T2, it is what? 6 divided by 3. 6 divided by 3, it is 2. Let's check T3 divided by T2. 12 divided by 6, it is the same as 2. So it basically means our ratio, it is equals to 2. Now we can now do this and find our term there, our what you call the one that the general term. Yeah, so now 3.1.1, let's start here. So we know that our a, it is what? 3, and our ratio, it is equals to 2. Now we can start now. So you're gonna write what? Tn, it is equals to a times r to the power of n minus 1. And then we are gonna say Tn, it is equals to, what is the value of a? 3 times, what is r2 to the power of n minus 1. That is the thing that we have. Don't say 3 times 2, it is 6, then you write 6 to the power of n minus 1. That is wrong. This is raised to the power of n minus 1. It is an exponent. So if you write 6n to the power of minus 1, that is now wrong. You lost your 1 mark. So guys, please leave it like this. It's fine. The second one, what do they want? They want calculate the value of k such that, so let me draw this thing here so that I'll be able to use my paper only to avoid many things. So 3.1.2, this is the sigma notation. K terms, like where there is k, that represents the number of terms, and then they are saying p is equal to 1. Yes, and then line I have 3 over 2, and then this, it is my general term of this thing. And then now it basically means the sum of this thing, it is equals to 98,301. I'm going to ask what this notation for sigma means the sum. So now they want the value of k. Okay, so now let's start. The first thing that you must do when you are seeing a sigma notation, wherever, as long as you see a sigma notation, whether they want the sum or whether they want anything, start by expanding. Wherever you see sigma notation, start by expanding. How do you expand? You write what you're given, 3 over 2 and 2, and then p, where there is p, you write what? 1, because they said that p is equals to 1, and then you say plus. So please guys, don't mind this one, don't mind it. So let me simply write it here, guys. 3 over 2 and 2 to the power of 1. Okay, and then you'll say plus what again? 3 over 2 and then to the power of what? 2, because you're now forming a pattern. So you must say 1, 2, 3, going on and going on, and you'll say plus 3 over 2. You are now forming a pattern. At least have 3 numbers, 2 and then 3, and then plus dot 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 to that one of whereby there is k there. Okay, but it's fine. After that, we have to determine the type of a sequence formed there. So 3 over 2 times 2. So this one will cancel. So I have 3 there, plus 2 squared, it is what? 4. So 3 over 2 times 4, it is what? 6, plus 2 cubed, it is 8. 3 over 2 times 8, it is what? It is 12, plus 3 over, I can say 3 over 2, where there is 2 ish, this thing, and then I put k there up there, because I guess you are looking for the value of k. After that, I can see that it is the same pattern that I was given. Then I can say my ratio is equals to 2. Okay, and then the value of 8 is equals to 1. But now, guys, I feel like I have to bring another paper here because now we are gonna work too much. Yes, so now we can now continue. So now, since you know that, I can right now I can do what, write my sum formula, some of this some of the sum formula of the what, of the geometric. Now, so I was given the what you call the ratio. I have the ratio, I have the value of A. So now I'm gonna use the what you call the formula of the sum. Sn is equals to A Rn minus 1 over R minus 1. Let me change my marker, seems like it is dying. Okay, it's fine. We are gonna continue there. And then now, where there is Sn, I'm gonna put what, sk. Angithi they're looking for the value of k. But now you will see what what we have. Angithi they've already told us about the sum of that thing, it is equals to 98,000 blah blah. So you're gonna substitute. So now, where there is A, I'm gonna put what, 3. And then my R is 2 to the power of k, because where there is n you put k. So where there is n, you're gonna put what, k, because according to the sigma notation, here it is the number of terms, right? And then where there is the number of terms, that's where they put k. So minus 1 over 2 minus 1. But we know that 2 minus 1 is the same as what, S1. And then where there is the sum of k, it is what, 98,301, as I was given there, right? Which is equals to 3 and then 2 to the power of k minus 1. When it is like this, you can do what? Divide both sides by 3. And then after dividing both sides by 3, you will have what? 32,767 equals to 2 to the power of k minus 1. And then when I take this minus 1 to the other side, it will be what? 32,768, which is equals to 2k. And then now you can do your what? Your logarithms. We go to, therefore, k is equals to log base 2 and then 32768. Therefore, my k is equals to 15. I have found my value of k there. Can you see how I did it? You simply had to use your logarithms, because there is no way that you can find your value of k. And then that's how you got it. I hope you understood, guys. But the main thing is that wherever you see a sigma notation, you must expand like this and then form a pattern. After that, check which pattern do you have, find the ratio, find the value of A, and continue there. So let's go to the next one. On the next one, they are saying that a geometric sequence and a arithmetic sequence have the same first pattern. So now they are basically telling me that you have the geometric sequence and the arithmetic sequence. Let's go on. The common ratio for the geometric pattern is 1 over 3. Okay, you have 1 over 3. And then the common difference for the arithmetic is 3. The sum of the 22 terms of the arithmetic sequence is 3734 more than. This one is very important, but we'll go there. More than the sum of infinity of the geometric sequence. So now, what we simply have there, it is the what? Arithmetic pattern and the geometric pattern. I'm gonna do these things simultaneously. In the arithmetic pattern, I was told that the value of A is the one that they want, so it is basically X. Same applies here, or the same as T1. And then now, the ratio this side, it is what? What was the ratio here? The ratio this side, it was 3. This side, it is the arithmetic one, so it is the common difference. It is equals to 3. Now, the ratio this side, it is what? 1 over 3. Under the arithmetic pattern, it is the common difference, not the ratio. I made a mistake. Now, you can write your formula, the sum formula. Sn is equals to n over 2, 2a plus n minus 1 times d. Now, I can substitute. So the sum, it is what? What is n? 22 over 2. I was told Mosogoti, it is the first 22 terms, right? And then now 2x. I know that x, it is the one that I'm looking for. So a, it is x plus what? 22 minus 1 times 3. And then now this is what? 11. And then 2x. 22 minus 1, it is 21. 21 times 3, it is what? 63. So plus 63. So this one, when I can just finish off and multiply everything, I'll have what? 22x plus 693. Now we are done with the sum for the arithmetic one. Let's go to the geometric pattern. Under this one, we are simply going to use what? The sum to infinity, because we were told to go to it is the sum to infinity. You know, guys, even if it is like this, we have the mark, we have got something, and then you will say what is a x over 1 minus 1 over 3. Is it fine? Now we are gonna continue. 1 minus 1 over 3, it is the same as 2 over 3. So this one will be the same as x divided by 2 over 3. But when I do my maths, it can be x times 3 over 2. You reciprocate and then you write a multiplication sign, which will then be what? 3x over 2. This is the sum to infinity, right? And then now, we were told, Uguti, the sum to infinity, but let me check my statement. We were told, Uguti, the sum of 22 terms of the arithmetic pattern is 734 more than. So it simply means, Uguti, on the sum to infinity, we are going to add what? 734. Okay, so now this one, it is the first 22 terms for what? For the arithmetic pattern. It is equals to the sum to infinity for what? For the geometric sequence or geometric pattern plus 734 that I was told, right? And then now this is what we have: 22x plus 693. It is equals to 3x over 2 plus 734. And then after that, from there, we're going to do our maths. But now check something. You have a formula, you have a fraction there, right? And you know that whenever you have a fraction, you must divide everything by, you must multiply everything by that fraction. So now when I multiply everything by that fraction, here I will have what? 44x plus 1366, yeah, 66, because I'm multiplying by 2, which is equals to 3x plus 1468. And then after that, I'm going to take 1366 to the other side, 3x to the other side, whereby I will have 41x, which is equals to 82. Divide both sides by 41, therefore my x, it is equals to 2. And then I can now seduce that t1, it is equals to 2. This is the first term of the two patterns, because they say that they have the first term. They have the same first term. That's all, guys, for patterns. I hope you enjoyed. Don't forget to subscribe. Thank you very much.